Hey guys, welcome back. Today we're going to be talking about absolute value functions. Now, for those of you who have watched a previous video on transformations of linear functions, you might be wondering, why do I still have this up? Guess what? What we're going to be doing today is all about transformations. The main form of an absolute value function is entirely based on transformations. So, here's what we're going to do. So, here's what I'm going to show you. Absolute value function. Oh, notice I will tell you what we're going to do today. So, I'm going to show you the basic parent function in just a little bit. Then we're going to learn how to graph it using transformations instead of trying to figure out points. So, we're going to be working with translation and vertical and horizontal translations, flexions over the x-axis, and vertical stretches and shrinks. We are not going to be doing reflections over the y-axis or horizontal stretches and shrinks because, one, they are pretty tricky, and two, they're not often used. They're not often used. I might talk a little bit about them, but it's not going to be very much. I will tell you that right now. Now, I will tell you that if you watch my videos on other transformations and functions, if you don't find them, then they're not released yet, then you will see that kind of stuff on there, even though they're not used very much. But anyways, let's get started. So I'm going to show you what the equation would look like. It would be f of x, function notation, equals a times the absolute value of x minus h plus k. Now, you remember what I was talking about in terms of translations. You look at these rules one more time. You'll notice that the h value would be a horizontal translation, k value would represent a vertical translation, and a value would show a vertical stretch and shrink. And if a value is negative, then it will be a reflection over the x-axis. Okay, so we're just gonna get started here. Alright, so first thing I'm going to show you is the graph of y equals absolute value of x, a parent function. Now you see why we are shoving this into the linear functions chapter, because it looks like two linear functions combined into one. The slope here would be about 1, negative 1 on the left side, and then once it reaches its vertex or turning point, it's right here, then the slope becomes its opposite. Same thing they have. Opposite. So that's how it works. Now let's try to start graphing other functions. So we're going to graph y equals absolute value of x plus 3 first. It's going to be a really small graph, guys. Okay? Just bear with me. You know what? I changed my mind. Plus 2. I want you to see it better. Alright, so absolute value of x plus 2. There's not much change from the parent function that I just given you, except for the plus 2. Since it's outside the absolute value grouping symbols, we just simply need to shift the vertex up 2. And then it will look something like this. Pretty basic. Try graphing x minus 1 now. Okay, so we have -1, so we need to shift the vertex down 1. And then since we have the same a value, which is 1, we just need to graph it with the same slopes. Should make a 90-degree angle about. Good, 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 good. Alright. How about we try this? Alright. Y equals absolute value of x plus 2. Okay, so notice that this is a horizontal translation now. Now, it is an addition sign, but that does not mean we go to the left, go to the right one. If you refer back to this, it's supposed to be negative minus h, not plus h. So when we have a plus h, we have to go to the left. Alright? So I'm just going to plot the vertex right here. And then there you have it. Got a little check mark there. Alright, and now I want you to try this. Okay, so we have x minus 3. Since we didn't change the sign from this equation here, we simply need to go 3 units to the right. And then graph. Alright. Now if you're confused about why now I'm just drawing stuff out for now. I will focus more. I will work on trying to get accuracy in the points that I try to make when we get to vertical stretch strings. Okay? For now, we're just gonna take it step by step. We're just gonna try and draw. Okay, so now let's see if we can combine transformations. So let's say I give you something like this. So we have absolute value of x minus 2 plus 1. How do we do that? Well, notice we got two different translations here. We got a horizontal translation, which is 2 units to the right, and then a vertical translation, 1 unit up. And so if we go 1, 2, 1, there's our vertex. And then that's how we graph. Alright, that was amazing. Yay, good job, you. Alright, now I'm going to let you try. Why don't you try graphing absolute value of x plus 1 minus 3. Alright, so we got two different transformations again. We have x plus 1, that means 1 unit to the left, and then down 1, 2, 3. Plot the vertex. Ta-da! Amazing, isn't it? Yep. Alright. Let's try adding a values to them. Alright, so let's see what we can do with this one. We have 2 times absolute value of x. So we have an a value outside parentheses. And that means we need to do a vertical stretch because it's greater than 1. what's the vertical stretch factor? It's right there. It's 2. So for every unit, that means for every unit unit x we increase by 1, we increase 2 units of y. So should have a very narrow v right here. Alright. Alright. Why don't you try figure out this one. Looking at that negative sign, what do you think it means? If you remember in my previous video on transformations of functions, you might be able to figure this out. So why don't you figure it out? Go on, don't be shy. Okay, so we have absolute value of negative absolute value of x. So remember in my previous video that we have, whenever we have the negative sign here, negative sign, the sign here, we have to flip it over. Flip it over the x-axis, pretty much. So we have the v shapes going up, but since we have a negative sign, we have to go down. Awesome. Yeah. Alright. Now, I know I wasn't going to talk about reflections over the y-axis, but I want to show you some. Now, it's okay, so this is the original function, right? Function, right? Okay, so notice that the vertex is at the origin. It's at the y-axis. Now, what would happen if we try to reflect it over the y-axis? This would happen. That's right, we get the same line. Now, that's only the case for if we get it. If we get the vertex on the y-axis. Now, if we had something like this is where it gets tricky. We actually had to get rid of that negative x. And so we actually end up getting y equals x plus 1. X plus 1. So what could have been this point right here just turned into this point. For Algebra 1 students, once you get to Algebra 2, hopefully you'll understand the reflections of the y-axis and horizontal stretch strengths a little better. There. That will happen in Algebra 2. Algebra 2. I just wanted to give you an idea of why I decided to skip that. You will not see me do this for a lot of the videos until we get to Algebra 2 content. Okay? Alright. Let's try some advanced functions here. Let's say you have 2 times absolute value of x minus 1 minus 3. Alright, so we got 3 different transformations going on here. What do we do, you ask? Well, I would suggest trying to write down the constant values using this equation right here. So identify the a value, identify the h value, identify the k value. What does all of it mean? And then graph it. Alright, so we have a equal to b1 because this is the number that's just outside the parentheses, the absolute value box. Our h value is positive 1 because there is no change aside from this. And then the k value is negative 3. Alright, so there is now I will tell you that there is an order in which we graph functions. Graph these kinds of functions. So I'm going to write them out right here. First, reflections. So if you have a reflection, get that done out of the way first. Second, any stretches and shrinks that you have on the graph. And third, translations. Alright, so let's see if we have any reflections to deal with. I would take a look at this and say we have no reflections because our A value happens to be positive, and if we have a positive A value, that means the V shape opens up. Stretches and shrinks now. Our A value is 2, and that means we have a vertical shrink. A vertical stretch with a factor of 2. And then we do translations. So we have our H value to be 1, so positive 1, and then our AK value is a negative 3, so 1, 2, 3. There's our vertex. And now we go up to left 1, up to right 1, and keeps going. Just trying to be as accurate as possible, guys. And there you have it, guys. That's how you do it. Alright, guys, I'm going to give you one more example. I'm just going to use my magic eraser here. Alright. So now, I need to erase that stuff as well. Alright. Now, I want you to try and graph this. Y equals negative 2 x plus 2 plus 2. Yep, I decided to give you a whole bunch of 2's, because I like 2. Because I like 2, do you get it? Alright, so try to graph a function. Use this 3-step process to graph the function. It'll make your life so much easier if you do it. So go on, take your time. Okay, time's up. Okay, so let's list our values first. We're going to list A value, which is negative 2. And then our H value is also negative 2 because we have a positive sign here. And then our K value is 2. H values are tricky, aren't they? Alright, so step 1 is reflections. Reflections to determine if the function goes up or down. We have a negative A value. Therefore, our V shape opens downward. Wah, wah, wah. Just kidding. Alright, and then our H value is negative 2. Oh, wait, not there yet. Stretches and shrinks. So, stretches and shrinks. So our A value is again negative 2. So that means we have to, if we go to the left in X value, we go down 2 Y values. And same thing on the other side. 1 X value to the right, 2 y values down from the vertex. Alright, and now we find the translations to find the vertex. So we have h value to be -2, so we have to go 2 units to the left. And then our k value is 2, so we go 2 units up. And then and now we can graph. So remember, we go down to right 1. Not my best effort, but whatever. Alright guys, that's it. Hooray! You've done an amazing job so far, hopefully. Hopefully you guys learned a lot through these videos that I'm making. Please make sure to subscribe and leave a like. If you really like this video, please share it with your friends. The better, the more help that students get with math, the better. So please tell your friends about this, and any other resources you have, of course. But hopefully you can take stuff I learned and put it in a good stance. All right. So thanks again, guys. Have a good rest of your day. See ya later.